Now, you're paying $20 for guitar lessons? Yes, what are the mean and the standard deviation of the number of sessions, guitar lessons that you're taking?
She just run down the hall.
0.
You just go walk over there.
Time.
We would do 0 times 0.4.
Plus 1.
1 times 0.3. 2 times 0.3. So that's 0.6, 0.9. 0.9. 0.9 is the mean. And then is somebody throwing it in the calculator to get the standard deviation? 0.83. Thank you. Okay. And if these guitar lessons cost you $20, then the cost is going to equal 20 times however many sessions you take. I am multiplying by 20. Is that going to change the mean? Yes. Is that going to change the standard deviation? Yes. So the mean all of a sudden is going to be $18. The standard deviation is going to be $16.60. Does that feel about right? All right, last one, and then we'll be done, okay? You're saving money to buy a new car. So your savings is going to represent your earnings minus your spending, yeah? And we said before the mean of our earnings was $69.50. And the standard deviation of our earnings was $16.50. All right, so what do we do? What is the mean of my savings going to be? On average, I'm earning $69.50 and I'm spending $18. So my $69.50 minus 18, $51.50. Everybody good? My standard deviation will be
1650.
well, so we have uncertainty about our earnings and we have uncertainty about our spending. We have two different sets of uncertainty here, yes? So you're going to do 1650 squared plus 1660 squared. 2341, sure. We'll do the normal ones tomorrow.
Oh, wait. Why do we do that?
Huh?
I'm at a loss. Why do we do that?
Okay, if we're adding and subtracting a constant, it would have stayed the same. I'm totally with you there. But the amount you're spending each week isn't constant. Sometimes you're spending $0, sometimes you're spending $20, sometimes you're spending $40. So when it's not a constant, you now have the uncertainty about what you're spending, the uncertainty about what you're earning. Your standard deviation needs to increase because you have two sets of uncertainty, one for, you with me? So it really boils down to like, you wouldn't describe it as earnings minus 18 because you don't know that it's going to be $18. In fact, you know you're not spending $18. Does that make sense? This is tricky. In my opinion, this is one of the more challenging conceptual topics. So what we're doing today is just going to be, one, it's not going to come anywhere near to taking the whole time. After that, you can work on your homework, your quiz review, whatever. The quiz on Wednesday is also, you will not have a block period to work a quiz. That seems a little bit, but it will be a long enough one because if you look at that quiz review, it is a little bit long, right? So you'll have enough time to finish the quiz, but I do intend to do content afterwards. Okay. All right. So I want to talk about what happens when, last week we kind of talked about when you're combining variables, whether you're adding or in this case we subtracted, how to calculate the new mean and the new standard deviation. Okay. The one thing that kind of jumps out that we also have is when those variables are normal, if I'm adding together two normal variables, the final result will also be normal. Okay, so let's go ahead and start thinking through this next question. And this is one where students have frequently wanted to do the wrong thing, which is why I'm maybe going to point this out, okay? So let's go ahead and say that the weights of adult men are approximately normal with a mean of 30. All right, so would you guys be comfortable with me saying the mean weight is 190 and the standard deviation of the weights is 30? Does that feel okay? All right, so now imagine I randomly select two adult men. So that could be I select Belk and Wyan, right? But it could be I select Peters and Richards. It could be I select Peters and Smith, right? And for each of these guys, I'm going to add together their weights. Is everybody good? So we want to think through I'm going to create this new distribution called T, okay? And T is going to be the sum of the first weight plus the second weight. And what I want to point out that I think where kids tend to start to falter here is this is not the same thing as saying 2 times somebody's weight. Do we understand why? Because those two guys are not necessarily going to be the same weight. You guys get what I'm saying? Okay? So this is two sets of uncertainty, person 1 and person 2. Now, this distribution T will be approximately normal because each of the initial ones were approximately normal. Now, what's the mean of the total weight going to be? Nope. It's going to be 190 for the first guy plus 190 for the second guy, which is 380. Because now, if I asked you what is the average weight of those two guys going to be, if we average those, that's a completely different process that we will leave to Unit 5. Okay? What about the standard deviation? What do you think we should do to find?
30 squared plus 30 squared and the square root of that.
The square root of 30 squared plus 30 squared. Perfect. And I think it's like 42 and some change.
42.4.
Great. Lovely. Now, how would this change if there were 3 guys? And T was now W1 plus W2 plus W3. Would it still be normal? Yeah. Which is quite lovely. All right, and what is the mean of T going to be? 190 plus 190 plus 190. I don't know why I wrote 198. And 570 it is. What about the standard deviation of t?
Add another 30 squared.
Just now you have 30 squared times plus 30 squared plus 30 squared. It's 52. 51.96. It's pretty close to 52. That wasn't from intelligence, that was remembering from last class. Okay, you guys. So imagine you walk up to an elevator that you know has a 700-pound capacity. And you already see 2 people in there. And you're like, should I get on this elevator or not? You guys catch my drift? So let's go ahead and say you're the 3rd guy to jump on this elevator. So now there's 3 guys. What's the probability it goes over the 700-pound capacity of the elevator? Well, we would say, well, what does the distribution of combined weights look like? It would be normally distributed
With a mean of 570.
and a standard deviation of 51.96. And I got to decide, do I want to get on this elevator? And to do so, I'm probably going to say, well, what's the probability that the total weights are more than 700? How do I do this? Normal CDF on the calculator. .6%, 0.006. Yeah, I would definitely be willing to be the 3rd guy. That's it. Let's do one more when you're ready. We're going to talk about Carter and Ricky.
She was showing me her
Normal distribution. That's really good.
I got it. All right, so the first thing I might do here is just write down some of those summary statistics that we might care about. All right. So if I want to figure out, did they finish within 5 minutes of each other? What should I do with their 2 times?
subtract.
I should subtract them, yeah? So we want to think through the distribution of Carter minus Ricky. Is everybody with me so far? And what would the mean of Carter minus Ricky be? 7. You would do 105 minus 98. A reminder that you would be expected to show that work, okay? All right. What about the standard deviation of Carter minus Ricky? We do the square root of 10 squared plus 15 squared.
18.03.
Remind me, is doing that square root thing, is that gonna work every time you're trying to find just the standard deviation of something minus another thing, or does it have to be normal?
No, that works no matter what.
Yeah.
Now, will the fact that this is normal means we can then use the normal distribution to do the work. Like if this was not, if we weren't given that these were normal distributions, we would run into some shape problems that we couldn't just use normal CDF to come up with our answer.
But you would still be able to use, to find the standard deviation.
To find the mean and standard deviation, it would be fine. Okay, so this represents all the ways they could finish, the times in which they finish within each other. Does that make sense? So what would it mean to say that they finish within 5 minutes of each other?
Finish. 5 minutes.
The difference has to be less than 5. All right, so you guys think I should just do 5 and shade all the way to the left? Okay, I'm going to give you a real quick for instance. What if it takes Carter 95 minutes and Ricky 102 minutes? Are they within 5?
No.
95 and 102? No. Their difference would be less than 5 because it would be -7. Do you guys see what I'm saying there? So it has to be between -5 and 5. And there's some nuance to this one, if you know what I'm saying. I feel like I need to make one, don't I?
That did.
He did?
Hit it.
One of them is.
It's the green one. It's the green.
Samples are not.
Nope.
That's funny. So this question has some? So what is the probability that -5 is less than or equal to C minus R less than or equal to 5? I think it's pretty unlikely still. I'm sorry? 0.2, so a 1 in 5 shot.
Can you explain again why it has to be 5 and -5?
So the difference, so if Ricky, who is supposed to finish first, finishes second.
Oh, but it's still in between.
Yeah.
I get it, because you're accounting for both.
Directions of the difference. Yeah. Another way we could think about that is what's the probability that they, well, no, that doesn't work. Never mind, I'm going to shut up now. All right, cool. I'm done for now. Homework, quiz review. You have a quiz.